Hey guys, my name is Dr. Huey, and I'm a psychology professor here at New York Institute of Technology. And today I'm going to be going over an example of a repeated measures t-test. So let me share my screen with you guys, and we are going to get started. As a reminder, a repeated measures t-test measures the same participant over multiple time points. So that's the biggest signifier of how you guys can know whether or not you should do that test, is if you're looking at the same people multiple times. So in our example, we're going to look at actually 5 students, my apologies about that, and they were tested on their cognitive abilities before and after an after-school STEM program. So the cognitive test ranged anywhere from 0, which was the lowest score you could get, to 50, the highest score you can perform on the cognitive test. And what we're going to do is we're going to measure the students before they do the after-school program and after they do the after-school program. What we're looking to see is whether or not there are differences in the test scores before and after the program. So here's our 5 participants. These are their scores before the after-school STEM program, and these are the scores after the after-school STEM program. And as you can see, some increased their score, some decreased their score. So we're looking to see whether or not there were significant differences from attending the after-school STEM program. The first thing that you want to do is you want to state the research and null hypothesis. So the null hypothesis is that the participants will show no difference in exam scores and cognitive scores before and after the treatment. And the research hypothesis is that the participants will show differences in their exam scores before and after the after-school STEM program. So as always, the null hypothesis states that there's no change, and the research hypothesis states that there's going to be a change. So the next thing that you want to do is you want to find the sum of squares. The only thing that's a little different about finding the sum of squares here is the first thing that you need to do is you need to calculate the difference score. So the difference score is subtracting the after score minus the before score. So in this case, you do, like for participant 1, for example, their after the STEM program score on their cognitive test was 30, and you subtract 30 by 20, giving you a difference score of 10. For the second participant, you subtract 50 minus 30, giving you a different score of 20, and so on and so forth. So you're going to use the difference score to find the sum of squares. So in order to find the sum of squares, you look for the deviation score first. The deviation score in this case is going to be your difference score. That's like your new piece of data minus your mean. So 10 minus 4 equals 6, 20 minus 4 equals 16, negative 10 minus 4 equals negative 14, and so on and so forth. Then once you get your deviation score, you're going to get your squared deviation score. So you simply square the deviation. So 6 squared is 36, 16 squared is 256, negative 14 squared is 196, and so on and so forth. And then you add those all together. So what you get as your sum of squares for this data set is 720. Then what you're going to do is you're going to determine your degrees of freedom and your population mean. So in this case, our population mean is going to be assumed to be 0. We're going to assume that there's no difference between the groups. So we're going to assume our null hypothesis and assume that there's not going to be any change in the before cognitive test and the after cognitive test. And that's why our population mean is 0. Our degrees of freedom is our sample size minus 1. In this case, our sample size is very small. It's 5. Minus 1 is 4. So our degrees of freedom is going to be 4. Step 4, we're going to determine the population variance. How you do that is you divide the sum of squares by the degrees of freedom, so 720 divided by 4, and our population variance is going to be 180. Okay, so we don't know our population variance, but we figured it out by dividing our sum of squares by our degrees of freedom, and we get 180. Then you're going to calculate the variance of the distribution of means. What you do in order to do that is you calculate the score that you just got, 180, divided by 5, divided by n, our entire sample. So 180 divided by 5 is 36. Then you're going to calculate the standard deviation of the distribution of means, and whenever you're going from a variance to a standard deviation, you simply take the square root. So the square root of our variance of population variance of our distribution of means was 36. You take the square root of that, and you get 6. Then you're going to calculate your t-statistic. So it's pretty straightforward. You do what your m is. So your t-statistic is going to be your mean of your current sample. So if you remember, our mean was 4. minus our population mean, which we talked about was going to be 0. And then you divide it by that standard deviation of the distribution of means that we got, which was 6. And our t-statistic is going to be 0.67. So the last thing that you do is you determine your sample score cutoff, and you determine whether or not you can reject the null hypothesis based on that. So we're using a 0.05 significance level. Our hypothesis was two-tailed because we didn't predict a specific direction. So we didn't say that we think that the after-school STEM program is going to increase exam scores or decrease exam scores. We just said that the scores are going to change. When that's the case, we have a two-tailed test. And so we can look at either of the tails. In this case, since we didn't define it, it could either increase or decrease. And then we have 4 degrees of freedom. So when you check your t-test, when you check your t-chart, what you see is 4 degrees of freedom and two-tailed at the 0.05 significance level. And our cutoff is plus or minus 2.776. Our t-statistic is way below that. It's 0.67. So there's no way that we can reject the null hypothesis. And basically what we need to say is, unfortunately, that the after-school STEM program treatment did not work, or it didn't work in the way we expected, in the fact that it didn't create any differences between exam scores before and after the treatment. So hopefully that helps, guys. The easiest thing that I can tell you guys is to just kind of walk through the steps. And if you follow the steps, it's an easy, it's not that hard to figure out a repeated measures t-test. And you are welcome to contact me with any other questions. Thank you.